All right. So we're going to take a look at section 8.3, question number 5. First of all, let's talk about the difference between section 8.2 and 8.3. In 8.2, we're looking at proportions. In 8.3, we're looking at means. Early in the semester, we started talking about discrete versus continuous, right? So that continues to play a role throughout the course of the semester. When we're using the binomial is a discrete probability distribution. When we're talking about the mean, so proportions are associated with the binomial. When we're talking about the mean, that's associated with continuous. So let's take a look at this problem. A data set includes data from student evaluations of courses. Summary stats are given, okay? The significance level is given as well. It's 0.10. So use this information to test the claim that the population of student course evaluations has a mean equal to 4. They tell us it's a simple random sample. We've got an n value that's greater than 30, so we should be good. Identify the null alternative, test statistic, p-value, and state the conclusion. All right, so let me come over here. And so I wrote down the information that was given in the problem. This is problem 5. N is equal to 92. So if n is equal to 92, then the degrees of freedom will be 1 less than that. Now, StatCrunch will calculate that for us, but it's worth mentioning. So X bar, that is the sample mean that we got from our data, is 3.83. S is the sample standard deviation, which is equal to 0.67. And alpha is the significance level, 0.10. So our null hypothesis is that the mean is equal to 4. Our alternative hypothesis is that the mean is not equal to 4. All right, so let me show you how to do this in StatCrunch. Also worth discussing is the t-distribution. What is the t-distribution versus the z-distribution? I'm going to make this very simple for you. The t-distribution must be used when the population standard deviation is not known. And almost always that is the case. Now, as the sample size gets bigger and bigger for the t-distribution, it approaches the z-distribution. So you can literally just always use the t-distribution when you're doing your hypothesis tests. So we're going to go to StatCrunch. All right, and I'm going to enter the summary statistics that I took down. So we're going to go to stat, and now we're going to go to t-stats for the t-distribution. One sample and with summary is going to ask us for the mean, which was 3.83. It's going to ask us for the sample standard deviation, which was 0.67. The sample size was 92. We're testing to see that the mean is equal to 4, or whether it's not equal to 4, and we have a significance level of 0.10. And then we hit compute. And there's our values. We have, our hypothesis test for the population mean. We have our sample mean, our standard error, which is, the standard deviation divided by the square root of the sample size. We have the degrees of freedom, which is 1 less than the sample size. Our test statistic, and then our critical t-value. And you can see our critical t-value in a two-tailed test would be plus or minus 1.66. Negative 2.43 is in the rejection region to the left of negative 1.66. And we have a p-value of 0.0169. That is clearly less than 0.1. So that's our answer, right? Our test statistic is, you know, is to the left of our critical value in the rejection region. Our p-value is less than our significance level, so we reject the null hypothesis, and we have sufficient evidence to conclude that the mean of the population is equal to 4. That is not correct. And that will conclude this lesson.